안녕하세요. I'm afraid that is as much Korean as I can manage. It is a pleasure to talk to you today. My name is Dr. Rowland Illing. I am the Global Chief Medical Officer for Amazon Web Services. I'm an academic interventional radiologist, and I still have academic appointments at the University of Oxford and University College London. I'm here today to talk to you about healthcare and life sciences, and in particular, genomics, and a very exciting announcement that we are making today. We've seen a massive adoption of cloud computing technology across healthcare and life sciences over the last 5 years. So I joined AWS in 2020, and there was a massive explosion of cloud computing due to the pandemic. The need to scale technology globally, securely, and quickly was really important. And so there are many reasons why healthcare is being delivered in the cloud today. There are many reasons. But the two reasons I see the most are the need for security and to manage healthcare and life science data in a highly secure manner, and also durability and availability. That is, the system needs to be on and available to have access to critical data, especially when it relates to patients. So around the world, in many other countries, we're seeing in-production workloads being used on the cloud. That is, healthcare data that is identifiable, patient-identifiable data running in AWS today. So we run protected workloads, for instance, in the UK, where the UK National Health Service runs on AWS for its national data spine. So we connect 44,000 different IT systems across the country with patient-identifiable data to allow access where it is needed. We have a global network of healthcare and life science end users, so national governments, health systems, research organizations, as well as a global network of partner organizations who are working with us to deliver better outcomes for patients all around the world. And I'm really pleased that we're working with a really innovative group of Korean healthcare and life science customers. One of those being Inocras, who we'll hear from later on in the presentation. But we have a really great group of customers and partners, some of whom are here as well, and please do talk to them if you have an opportunity, and many of them will be in the audience today. I'm delighted that we actually have over 80% of global healthcare and life science unicorn companies are built on AWS. 9 of the top 10 global pharmaceutical companies have their drug discovery platforms built on AWS, and 4 of the top 5 genomic sequencing companies are partnering with AWS to build out the latest genomic pipelines and applications for end users. Last year, we won the Best in Class, so KLAS is a global benchmarking organization that looks at various solutions for healthcare and life sciences. We won the Best in Class for healthcare in the cloud, and were top rated by IDC. So again, I'm delighted that we're working with end users and partners to deliver these kind of healthcare and life science solutions at scale globally and are recognized. We work with many partners and customers specifically around artificial intelligence in healthcare and life sciences. And we've learned a lot of different lessons since 2022 when ChatGPT was launched. And I'd like to take you through some of the things that we've learnt in that time. There are certain keys to success that are common amongst those that are doing really well. The first is having a really strong data foundation. And this talks to, if you've just come from the keynote, this talks to some of the things that the keynote has also talked about are also true for healthcare and life sciences. So having a strong data foundation is essential in order to really leverage AI at its fullest. So in healthcare and life sciences in particular, data tends to be very siloed within the applications and the systems of record within healthcare and life science organizations. And so how we can build accessible data is a key consideration. And we're building out certain solutions such as the Amazon Data Zone, which is a data mesh solution which allows data providers and data consumers to access data across organizational boundaries. And that's within organizations as well. And this puts in guardrails, it puts in rules, it puts in governance, which means that only the right consumers are allowed access to the right data sets at the right time. Once data is organized appropriately, we have the right tools to then build AI foundation models and AI algorithms. And as the keynote mentioned, we are building our own silicon, and we have Amazon SageMaker Unified Studio, which has all the tools available to store and manage data, govern it, act upon it, and then really build out the next generation of foundation models. Now, we hear a lot about large language models. When it comes to healthcare and life sciences, we're seeing an explosion of large data models. So not just language, but multimodal models, which include imaging, that's DICOM data. It can be radiology or pathology or visible light data, and also omic data, so genomic, transcriptomic, proteomic data, to go into these large data models. And so we've seen some of the first large data models for imaging being launched on AWS. We have Hopper, Harrison AI, GE has launched a foundation model for MRI. Also Philips is launching that foundation model as well. So once we've built the foundation models in a secure environment using secure data sets, then it's how you build AI applications. And I'm delighted to see Amazon Bedrock as a stand in the hallway, and definitely go and have a look at Bedrock. We're seeing a lot of organizations leverage Bedrock as a service to tap into these large data models through API calls. And so now we're allowing healthcare and life science organizations to build healthcare applications faster using Bedrock as a service. Because it has all the things that you need to have those secure guidelines, model choice evaluator, so actually compare different models, guardrails, and then secure customization of those models using your own data. For instance, the University of Essen were able to build an application called Cell on Cloud in just 72 hours, taking large data models, imaging in pathology, enriching it with their own data, and actually producing their own model and as an application in 72 hours. And if you're interested, you can actually see that model live. So we've released the Health AI Hub. So the Health AI Hub has 3 attributes. It's a front door. So if you're interested, you can actually sign up for early access, And the first part of the Health AI Hub is actually looking at third-party applications that have been built using Amazon Bedrock on AWS, and you actually will get a chance to play with those applications and different data sets, and you can use them yourself and see how they operate. If you are building applications, I would love for you to be the first Korean application on the Health AI Hub. That is my challenge to you all today. Who will be first? The second part of the Health AI Hub is a lab which will allow you to play with the tools like Bedrock and open source data sets, and you can actually put applications together and see how it works. And then the third element is the knowledge element, where actually there's educational detail there about healthcare and life sciences on AWS, and it'll allow you to explore that further. And of course, once we have a foundation of data, and we've got the tools to build on it, Amazon SageMaker Unified Studio, we've got the foundation models built and applications built, the final step is this agentic AI, as was mentioned in the keynote. And we're seeing an explosion of use cases for healthcare and life sciences. And again, my analogy for agents is that if you can think about a football game or a soccer game, the large data model, the large language model, is like the coach. So all of the information, all of the knowledge resides with the coach of the football team before the game. All the information you need to win the game is there. But when you actually get onto the pitch to play the game of soccer, you actually need the ability to interact with the environment and respond to events in real time. So you can consider the agent as the captain of the football team, taking all the knowledge from the coach, the large data model, but actually reacting to the environment that it's in real time in order to achieve an endpoint. So the coach of the captain of the football team will look at where the ball is on the pitch, and the agent is an autonomous piece of software that can achieve an outcome, which is to win the game. But of course, like any bit of scientific discovery, it's never one person. In actual fact, what we need are a team of people or a team of agents all working together to achieve a goal. So when we're talking about multi-agent workflows, multi-agentic AI, we're actually thinking about a supervisor agent, the captain of the team, working with lots of different specialized agents. In the soccer, it would be forwards or defenders. When it comes to scientific discovery, we could have knowledge agents understanding the literature. We could have specific agents building molecules to address targets. We could have specific agents writing academic papers based upon the outcomes of the research agent. You can have peer review agents then looking at the outcome of the publishing agent. So a whole stepwise process where agents can work with each other to achieve a goal. And we are seeing a proliferation of agents across healthcare and life sciences, from drug design to clinical trials to different types of research. For example, Wiley, who's one of the scientific publishers, are developing agents for their own scientific discovery. Typically, a lot of research takes place on PubMed, just looking at the abstracts, not necessarily going into all the papers, just looking across all of the abstracts that have been published to try and define what research should be done. Wiley are developing a series of agents that can really look very deeply, not only at the abstracts, but also at the type of research that's been done, the type of research, the level of evidence, to come out with some really interesting new scientific discovery. We worked with Genomics England, creating a large data model for their biocuration services. They have 40 biocurators. We worked with Genomics England to develop a large data model to assess the scientific literature, to look at genomic associations with new types of disease. Using this large data model, they were able to identify 20 new genes associated with learning disability that were previously not known. And so now they are targets for genomic medicine for the UK Genomics Medicine Service. Not only that, we're developing specific services on AWS to manage data types. So in order to build applications faster, we know that there are some core elements that need to be done no matter what kind of application you're building. If you want to work with text data, it's important to be able to work with the standard of text data, that is the FHIR standard. If we work with imaging data, it's important to work with DICOM standard. And so where we're working with imaging data, we built AWS Health Imaging, and that can ingest DICOM data, intelligently tier it, and stream it into imaging endpoints. And so we're working with some of the largest imaging companies, GE, Siemens, AGFA, about building out their next generation of PACS solutions, picture archiving and communication solutions built on AWS. Similarly, for text data, we have AWS Health Lake to ingest structured and unstructured text data that can then be put into the FHIR format. Similarly, for genomics, we built AWS HealthOmics, which can ingest different types of omic data, genomic, transcriptomic, proteomic data, store it, and then stream it into genomic pipelines. And I'm delighted to say that today we can announce that AWS HealthOmics will be live in the Asia-Pacific region, that is, in Seoul. And so now all of you can work with AWS HealthOmics to build out new and novel genomic applications. So organizations are leveraging HealthOmics, bringing new tests to market in the clinical space, building new bioinformatics workflows, and also using the latest biological foundation models to build out massive computing power through API calls. HealthOmics has workflows built in. They'll have fully managed infrastructure and workflow engines that can automatically scale to your needs. As I said, we can run single runs with single API calls, run workflows at scale, scale up and scale down as needed, and have very predictable cost because you only use what you need. And we have life science customers around the world using AWS as a platform to build out the latest generation of scientific discovery. These are just a handful of those customers. We've got hundreds of petabytes of data now stored on AWS, analyzing thousands of samples, running tens of thousands concurrent tasks every day on our AWS infrastructure. Now, it is my absolute pleasure to introduce Mr. John from Inocras, who will be talking about how they are leveraging AWS HealthOmics to scale their business and deliver outcomes for their patients and their customers across Korea and around the world. So, Mr. John, over to you.
네, 안녕하세요. 오늘 글로벌 헬스케어 산업의 디지털 전환 AWS 사례 발표를 맡게 된 이노크라스 데브옵스 팀의 정다운입니다. 오늘 발표를 통해서 이노크라스의 헬스오믹스 도입에 어떤 시스템 인프라 변화 과정들이 있어 왔는지, 그리고 AWS 오믹스 도입을 통해 어떠한 효과를 확인했는지 공유드리고자 합니다. 먼저 저희 회사에 대해서 간단히 소개드리면서 시작하겠습니다. 저희 이노크라스는 2020년 설립한 유전체 분석, 해석 전문 기업입니다. 특히 전장 유전체 데이터 분석과 해석에 집중하고 있으며 그간 누적된 정보를 기반으로 AI 플랫폼을 준비하고 있습니다. 회사는 미국, 샌디에고 본사와 서울, 대전, 그리고 홍콩에 거점을 갖추고 글로벌 비즈니스를 진행하고 있습니다. 저희는 100만 개의 암 유전체를 해독하고 이를 기반으로 하는 데이터 레이크와 전장 유전체 AI 플랫폼을 통해 정밀 의료의 혁신을 선도하는 것을 장기적인 목표로 삼고 있습니다. 목표를 달성하기 위해 AWS, 울티마 지노믹스, 코넬 의과대학 등 많은 곳들과 함께하고 있습니다. 앞서 말씀드린 것처럼 이노크라스는 전장 유전체 분석에 집중하고 있습니다. 전장 유전체 분석을 위한 시퀀싱은 유전체의 특정 영역만을 시퀀싱하는 타겟티드 패널 시퀀싱, 홀엑솜 시퀀싱과 다르게 유전체의 전체 영역에 대한 염기서열 분석을 수행합니다. 따라서 홀지놈 시퀀싱은 다른 시퀀싱에 비해 10배 이상의 데이터를 생산하게 됩니다. 이노크라스는 통상 사람 한 명 데이터를 처리하기 위해서 약 1TB의 저장소를 필요하다고 계산하고 있습니다. 이런 큰 데이터를 처리하고 분석하기 위해서는 높은 처리량을 요구하므로 대규모 분석 시스템이 필수로 여겨지고 있습니다. 오늘 발표를 통해서 저희 이노크라스에서는 이런 대규모 분석 시스템을 어떻게 운영하고 있는지 소개드리고자 합니다. 이노크라스의 유전체 분석 시스템 인프라는 크게 온프레미스, 클라우드 마이그레이션, 클라우드 네이티브 3단계 과정을 통해서 변화해 왔습니다. 그중 오늘 AWS 헬스오믹스 서비스에 기반한 클라우드 네이티브 시스템에 대해서 이야기 드리고자 합니다. 저희는 클라우드 마이그레이션을 리프트 앤 시프트, 가능한 기존 분석 시스템을 그대로 이식하는 방법으로 진행했습니다. 시스템 설계에는 높은 성능의 HPC 구성을 지원하는 AWS의 패러럴 클러스터와 FSx4 러스터를 활용했습니다. 저희는 2022년 5월부터 지난 3년간 평균 120대 이상의 연산 노드를 미국에서 운영해왔습니다. 본격적으로 이노크라스의 고객이 증가되면서 몇 가지 고민이 생기게 됐습니다. 예상보다 많은 수의 주문을 접수받게 됐고, 이는 내부 예상치보다 높은 수준의 컴퓨팅 파워와 저장소에 대한 요구로 이어졌습니다. 저희는 이를 효율적으로 관리할 수 있는 시스템을 고민했고, AWS 코리아에서는 가장 적합한 서비스로 AWS의 헬스오믹스 워크플로우를 추천하였습니다. 이노크라스는 추천받은 AWS 헬스오믹스에 대해서 AWS 코리아와 함께 6개월 이상 기술을 검토하며 다음과 같은 주요 포인트를 확인했습니다. 헬스오믹스는 공식적으로 대규모 워크플로우 실행을 지원합니다. 이는 헬스오믹스의 특징인 완전 관리형 인프라스트럭처 및 워크플로우 엔진 덕분입니다. 기활용하던 패러럴 클러스터의 경우 슬럼과 같은 별도의 워크로드 관리 도구 및 컴퓨팅 리소스 인프라를 파이프라인 구동 전에 구현했어야 했습니다. 헬스오믹스에서는 사전에 인프라를 구축하지 않고 워크플로우에 정의된 컴퓨팅 리소스에 따라서 인프라를 구현합니다. 따라서 요구사항 변화에 따른 인프라 관리가 훨씬 유연할 것으로 확인하였습니다. FSx4 러스터의 경우 워크로드 특성상 분석에 필요한 스토리지 전체를 상시 유지했어야 했습니다. 헬스오믹스에서는 필요한 고성능 스토리지를 자체 관리하여 자동으로 확장하고 활용이 완료되면 삭제하므로 더 효율적으로 스토리지를 사용할 수 있을 것으로 확인했습니다. 이노크라스는 이런 예상을 기반으로 헬스오믹스 도입을 진행했습니다. 이번 헬스오믹스 도입을 통해 분석 비용을 약 72%, 분석 속도를 약 47% 개선하였습니다. 또한 확장성은 4배 이상 개선되었습니다. 이는 AWS 헬스오믹스의 스토리지 관리 기능과 유연한 연산 노드 확장성에 근거했기 때문에 가능한 수치였습니다. 저희는 이미 MRD 비전이라는 헬스오믹스 워크플로우 기반 상품을 25년 4월 미국 시장에 출시했습니다. 또한 기존 상품인 캔서 비전의 헬스오믹스 워크플로우 도입 및 시스템 전환 준비를 완료했습니다. 캔서 비전은 한국, 미국 등 글로벌 서비스 중인 제품으로 한국의 헬스오믹스 서비스 출시 여부가 이런 시스템 전환의 중요한 포인트였습니다. AWS 코리아의 전폭적인 지원 덕분에 이제 한국에서 헬스오믹스를 사용할 수 있게 되었고, 이번 변화는 이노크라스의 목표 중 하나인 데이터 레이크와 전장 유전체 AI 플랫폼 구축에 큰 도움이 될 것으로 예상합니다. 이상 마치겠습니다. 감사합니다.